Several of my students have been struggling with this kind of problem, so I thought I'd make a video for you guys on it. It asks you to basically show that this thing will always have two roots no matter what the value of p is. And x is squared, so it's a quadratic equation, and p is just going to be some constant value. But it wants you to show that this thing has two roots no matter what you pick for p. So if it's 0 or 10 or a million. And for quadratic equations, there are a lot of tricky ways to factor, but since p could be anything, factoring is not such a good idea here. So we're just going to go straight ahead and use the quadratic formula. And there's a little bit of a bonus here with this problem, because if you're sort of tricky, you only need to use a small part of the quadratic formula. And I'll show you why. I know a lot of students don't really like to, it's a little bit bulky, right, this whole thing. Now, it wants to show that we have real roots. So look at this thing and think to yourself, which part of this formula could sort of create an imaginary number or something that's not real? And by imaginary, I mean, the imaginary number I is just the square root of -1. So the square root of any negative number is going to make something imaginary. So all we really care about for this investigation is this term here. And you call this the determinant. What does it determine? If you put everything in for b and for an AC and it comes out negative, you have determined that there are 0 roots. Okay, if it's 0, you determine there's 1 root, and if it's a positive number, there are 2 roots. This kind of makes sense, because imagine if it was 0, okay? You'd have plus or minus 0, so the only root would be minus b over 2a, right? If it's a positive number, you're going to get 2 different numbers, so that means you have 2 roots. If it's imaginary, well then, no real roots. So, I'm not even going to do these parts, okay? So you don't really have to either. It's not actually asking you to find what the roots are. You just need to prove that there will always be 2. So let's just look at what the determinant is. b squared minus 4ac. 2 is a, b is 2 times p+1, and c is just going to be p. So I'm just going to write out what b squared minus 4ac would be. And that's going to be 4 times p squared plus 2p plus 1, just squaring the p+1 term there, and then minus 4ac minus 4 times 2 times p, and you get 4p squared plus 8p plus 4 minus 8p. And something really nice happens here in the simplification. You see the 8p will cancel out with a minus 8p. So your b squared minus 4ac term, determinant, right, determining what kind of roots we will have, is just this. You have plus or minus this over other stuff that won't make it imaginary, with another term here that won't make it imaginary. And what value can you put in here for p that would make this whole thing negative? Nothing real, okay? Say you put 0 in, then you'd have 0 plus 4, so square root of positive 4, that's fine. If you put in a negative number, it gets squared and goes back into the positive realm, etc. So this will always be greater than 0. So therefore you have to have 2 roots for any real value of p. If you start putting in like negative square root of 1 values for p, then you could get something negative under there. But this one is kind of assuming you stay in the positive realm. So if you have any more questions on this, looking for any clarification, please post them in the comments. And you're also welcome to send me a message directly. Thanks for watching.